And the next topic is about introduction to the Computer Science 547, which is software measurement. Dr. Cong.
Oh, just put it in the pocket. Okay. This one somewhere.
Which one is mine?
This one? No.
This one is
No, that's not mine. Yeah. Okay. Welcome. Thank you for coming. I'm going to spend a little time just give you some general idea about 547, the software measurement. Give you some idea, what we're going to do and how we're going to do it, and some of the important concept and maybe the value of the class, what you might need to learn. I guess most of you, maybe all of you had a class with me before, right? So I taught 546 last semester, and also some of you took Project 1, 597-1 with me. So you probably have some idea typically what's my approach, how I do things. Textbook. So this is, I guess, one of the better textbook in software measurement. Software measurement is kind of unique. 542 is unique, but this is even more unique. So typically, you're a user, the customer, they probably don't care how you measure throughout, right? And they just want to know the end result. But this has actually become very, very important. Measuring the software process. So this is the only book, okay, and that covers something we call that statistical process control in software engineering. Okay, SPC, I guess some of you may have heard this before, and it's used very successfully in manufacture, in many other fields. Okay, so we try to apply this in software. So they're not, because the uniqueness of software. Okay, when we do software development is not like a manufacturer. So you see, you try to produce this. Every time, the process is exactly the same, right? Totally repeatable. Okay, so obviously it's easier to apply some of the statistical techniques. But software, do you have ever two projects go through exactly same process? Every project will be different. Every project will be unique in certain aspect. Every project will involve some uncertainty, right? A requirement for sure, and sometimes even technology. So sometimes you don't have to change your design. Sometimes you don't have to change your architecture. So that means, it's very difficult to figure out everything in the very beginning. So you learn a lot before we talk about all those agile, lean, how you can actually reduce the rework. Okay, you don't have to do everything right first time. So that will present a challenge in measuring software project, software product, and software process. So this is actually one area we're not doing that well. For example, we still have trouble measuring the size of a software system. Okay, and that actually deals with the contract. Okay, and so this is the reason we use this as a textbook, because this is recommended by Humphrey. Okay, so I guess we are a big fan of him. Right? And very inspirational, to this program. Okay, and also this is the only one that actually gave you concrete example on how to apply SPC in software. Okay, I give you a few additional references. One of them is actually the textbook you use in 542. Okay, so if you look at chapter 11 and 16. Obviously, software measurement, one of the big topic is how do you measure the software quality. Okay, so that deals with defect. Okay, so that's a big part of testing. Okay, so some of the stuff, chapter 11 to 16, I think can also, there are a lot of overlaps between the courses, you probably find out. So this is one area. There's an overlap, particularly dealing with the topic. The second one, actually, Christopher recommended this book. Okay, Elementary Statistics is really an excellent book. Okay, so a lot of great example. And one thing, the engineer, as an engineer, we need to do, we need, so in this program, you learn process thinking, right? You don't make it a one-time deal, okay? And think from process point of view. That's how you do defect prevention. That's how you prevent the same error happen over and over again. And that's how actually you want to make sure you repeat your success. Okay, the best practice. And statistical thinking is another thing. I think is also a very important skill for engineering, including software engineering. Okay, so this work give a lot of life example. Okay, so make statistics really fun. Okay, so CRI. Okay, so now it's 2.0. Okay, well we still do 1.3, but some of the basic ideas pretty much the same. And I'm gonna, so I add a couple of other reference books, 6 and 7. You don't have to buy it, just in case if you're interested in the subject. And so here are some of the references. And I'm gonna also post some of the more recent stuff. Some of you probably know I'm a big fan of Ronaldson, the guy who did the next generation Lean. Okay, and he also got some new ideas about some of the software measurement. So you probably can learn some of the new development in the field. Okay, the work is similar at discussion board, same as before. You probably know I really like to use the discussion board. I try to come up with some unique topic. Okay, and a lot of you, did a great job in my first class. Particularly for those of you who share your own experience. Software engineering is not black and white. Okay? Every problem, every situation is different. So the idea is apply the principle. And solving the problem, engineering is you don't need to come up with the optimal solution, but we need a solution. We can always get better. Okay? One thing, I think I really like about MSE, we've been doing this so many years, is we have a lot of students with a lot of good background experience. So discussion board provide a vehicle and also a platform for us to learn from each other. So you not only learn from the instructor, and also I think it's important to learn from your fellow student. A lot of students coming from a major company, you're all great practitioner. You do things. You are involved in project. You solve daily, problem, real world problem. Those experiences and the challenge, good or bad, I think will be very useful. So same thing. Okay, so appreciate. You put some thought. I read all of them because I learn quite a bit from you too. In terms of grading, I'm always, you probably find out, I'm very generous in terms of the discussion board. Okay, so sometimes it's not, it's very difficult to say it's right or it's totally wrong. It's just, it depends. Okay, it depends on the context, but, same thing. Okay, and usually I give you, at least 2 weeks, okay, in advance. So, make sure you do it. You have 2 weeks anytime when you have time. Plan your time carefully. So there's a final exam. I'm similar. Give like a 2-group assignment. Okay, so again, try to come up with some interesting topic, and you maybe need to do a little bit research, do some work, combine with your experience, hopefully come up with something unique, and also a one-term project. Okay, so I always put a lot of weight in a group project, and try to simulate some like a real project. So learning by doing. Okay, so this is engineering, and also, maybe you have a different interest. So in this way, software measurement is kind of, it's not that, a big open area, but it's still, it's big enough. It's always a good idea, select one specific area, then go deep. Okay, and so I think, a group project, so that will be a good ways of doing that. Okay, so same thing as before. Okay, 90A and 80B 70C, 60D, okay? And I may curve a little bit, if it depends on we try to have some sort of a normal distribution. Okay, so here are some of the objectives. A practical approach in measuring software engineering activities. So if I already post all the lectures based on the feedback online. And make sure maybe when I have time, start to look at this. In software, okay, let me give you an example. I've been a struggle. I try to lose some weight. I've been doing this for many, many years. Imagine you try to lose weight without a scale. Imagine that. Okay? Well, you can. It's possible to lose weight without scale, right? But it's going to be awfully difficult, inconvenient. You do different things, you try different things. Is it working? There's no feedback. You need to get feedback. But even I give you a great scale, does that guarantee you can lose weight? No. So measurement by itself will not survive. But if you truly want to improve something, you truly want to achieve something, you always need a measurement. You need to know if it's working. How far I am, from the goal I try to achieve. Should I make any adjustment? Okay, in software, we don't do this very well. Software engineering is actually the area where you don't do a great job comparing to civil engineering, electrical engineering, and we always get things done. But if you look at deeper, with a lot of rework, okay, we're not that efficient at all. Okay, and imagine you drive a car without a gas meter, without knowing how much gas left. Can you still drive a car? Yes, you can still drive a car. Okay, but it's going to cause a lot of inconvenience for you, right? Okay. In real life, we use metrics all the time, to make things easier for you, to help you make adjustment. Okay. But when we drive a software project, in many cases we drive that car without a meter, without knowing if it's working or not. For example, you do system test using 542. I identified 500 bugs or defects. Is that enough? Do you have any idea, knowing that, okay, how many additional defects must be escaped to the user? Okay, you're doing different things. Is it working? Okay, so basically, one thing we need to learn to use is the so-called how we actually use measurement in this. Before Humphrey died, he did an interview the year before. Okay, and they asked him about, what do you think about Agile? Okay, so because the Agile movement is big, he's CMI, he's the father of CMI. So people always have an idea CMI is a heavyweight. Right, so Agile is, opposite, but which is not true. That's a different story. He basically said, he actually looked at Scrum. He said, that's a great framework. Okay, and Scrum actually talk about discipline. There are a lot of things you have to do. There's the discipline, and he said, as long as you have two things, you have a framework. Usually, it's complete, covers the different things, and you execute it with discipline. And plus, having a metrics, knowing if it's work or if it's not working, so you can make adjustment, right? You have these two things, you're going to be okay. Okay, so that basically tells you the value of metrics. And how we measure, a software product, project, and process, and there's the concept of ROI, return on investment. So same thing for measurement. Every measurement usually involve a lot of cost, right? So these days, usually they are automated. You define a measurement, you have to define a lot of things. We call that operational definition. And then you have to collect the data. Somebody had to analyze the data. You have to put in the report, right? It's a lot of cost. What's the value? What we got? Okay, and because particularly in software projects, usually under pressure, there's a deadline. Okay, and how are we managing that? So we're going to learn all those things this class. Metric dictate behavior. Okay, and how we use this effectively, that's also important. CMI now is 2.0, so they have a concept. Obviously, it's the value. You know what? Using one statement to tell you the difference between the old CMI and 2.0. They claim they changed CMI from a process improvement model into a business performance improvement model. What's the bottom line? Another slogan is do more with less. That's actually, there's a quote, direct quote from the CEO of Raytheon, because with all the competition, all the challenge, okay? And so this is particularly true in this field, because a lot of people think measurement is something not asked by the user. They may not even pay for the work you did in this. Why we still do it? Because it's necessary, because it's going to give us some value, but we need to understand that. So that's kind of important. And also, learn some of the best practice in the industry, particularly the most recent development, okay? Particularly with the next generation of lean. Last semester, I mentioned, if you recall, there's a metric called the cost of delay. Okay, so sometimes a metric is not just a definition of measurement, also imply a new methodology, new type of thinking, new practice. Okay, so maybe, hopefully that can also help you in your work. And also, this is the metric is dealing with CMI high maturity stuff, level 4, level 5, statistical thinking. Okay, so we're going to cover that in the class 2. I'm not going to go through all the details. So here is the topics I tend to cover. Okay, and some of the important dates. So make sure you read the class syllabus I posted. All the dates. I'm going to just make sure you see everything. I'm going to create another one. I call it important dates for the class. Okay, so take a look at this, okay, and also tell you when. I'm going to give you homework 1, homework 2. Okay, so different topics. Okay, and I'm going to also post, I call that the possible project topics. So here are some of the stuff, just some example. Okay, so depends on what do you like. Okay, and kind of very broad. Okay, just give you some idea. But if you have something unique, I think that would be great. If you can relate to your work, that would be even better. Okay, so we talk about use of functional point. Okay, and which is this is very popular. Is one of the better metrics. That basically separate implementation from the feature. Okay, and we talk about SPC, how you use all the different control chart. Okay, so maybe take a look. And some of the, you talk about Agile, Kanban, next generation of Lean, and DevOps. So I'm going to actually post a little bit more material for DevOps. So, this is also related to 542. See, so you do auto testing, you do continuous integration, continuous deployment, okay? And obviously, then how about operation? So basically, we try to go from end to end. Okay, the metric is the same thing. Okay, so reliability growth model is kind of if you Google this, it's very interesting. How do you know you test enough? I can stop testing. Okay, so this is the idea of apply reliability growth model would be great. So they give you some ideas. So that's a perfect example. Apply numbers, data to help you making a better decision. Okay, and Kokuma. Okay, Barry Bean, how do we do estimation? Okay, and contracting and complexity model, there are a few other things. Okay, and I'm going to post possible topics very soon with some new additional stuff. But you are not bounded by this at all. Just like before, what I need you to do is, you form a team, right, and write an abstract, a proposal. Okay, so send to me, I'll take a look, give you some feedback, and so we reach an understanding. Okay, just make sure it clearly defines scope of work, objective, role, and responsibility. Who is doing what? Just like, similarly in a real project. Okay, and have a goal, and have a plan. And, you have a whole semester to execute, carry it out. Okay, here are some of the dates. Okay, you can take a look, and you should be able to also to find them. My syllabus. Okay. Any question? It's kind of difficult to ask questions with this type of reason. Okay.
Can you go back to the previous slide, please?
Oh, sure. This one?
Yes.
Okay.
The homework 1 and 2 is also with teams? Or
Yes, with teams. Okay. Yes. Yeah, because so typically you might need some research. Right. You might elaborate. The thing is, I just want you to demonstrate it. You learn this, you can actually use it to apply something. Okay, so you don't have, I won't ask you to memorize anything. Okay, so, apply in a certain specific context. And another thing is because this field is so dynamic, it changes, new stuff coming out all the time. And homework, I think that's another way. I'm going to force you to do some digging, do some Google, and check, and then think. So if you have a team, you guys can discuss, and maybe come up with some unique stuff. And another thing, I just put one more statement. In project, in homework, and also in posting, okay, try to come up with something unique, practical. Okay, so hey, this is engineering. Okay, so this is, we have a student younger, huh? Right. Okay. Yeah. Oh, it's so good to be young. Any other question?
The final review topic is in regards to the same class project?
No, this is for the final. Okay, so give you some idea. Maybe I might give you some sample questions, sample stuff, okay, to help you prepare the final a little bit better. Yeah. Yeah.
Can you elaborate and give us a little more details of what you're looking for in the group project?
In the group project, sure. I'm going to send out more detailed announcement later. One, I want a very well-defined topic, okay, clearly specified. Okay. Number two, I love something specific. Okay, so I just want to do this. And number three, define this, and then you have like a few people, right? You have a team, clearly define who is doing what. Okay, role and responsibility. Another one I'm looking for is a good plan, right? So you have a good plan is a good starting point. You are 1/3 way out there, okay? And you have a semester, so typically so we have what? This is fall, right? It's not spring. So we have about December, I think I have the date, so you're supposed to submit everything December 12 or 15, I forgot. Okay, so, so plan it out, okay? And also also explain what's your approach you guys going to work. For example, we could do it incrementally, iteratively, okay? Or you're going to have, you do this, you guys need to communicate, right? So you need to have someone to do it together. And some people asked me before, what's the minimum length? I don't have minimum length because we reach understanding in terms of scope of work. Okay, based on that, if you can explain everything in 10 pages, don't do 11. Okay, you waste your time, wasting my time. Okay, so I am the reader. Okay, so the length of a report depends on the background knowledge of the reader. So you're right, so don't worry too much about the length. So don't copy paste a lot of stuff useless. Okay, so unique stuff, something new, something unique. If you have some working experience, I love the type of stuff you apply this to your work. You combine your schoolwork and daily work, that'd be great. Okay, I appreciate that. I also wish, I'm a little bit selfish, I want to learn from you too. Okay, what kind of challenge actually you guys facing? So it's, or you do some study, comparative study, but you try to have some niche, some point. Okay, so you can elaborate. Okay, survey type of thing is okay, but if you do survey, I would prefer you do some comparative study. Okay, like come up with a user's guideline. So what's the value? When other people read it, so I want to study two approach. When should I use this one? When should I use this one? Why this is better? See, when you have multiple methodologies, it's always a trade-off, right? Otherwise, you only have one. There's a reason for the existence of anything. Okay, so if you can elaborate and think of the word of value, you write it, what would be the value? Yeah. Any other question? Yeah. Same as before, I guess 5, 6, yeah. Because if it's too small, you probably can't do too much. If it's too big, Dr. Joe mentioned, the communication, the other costs could be also high, right? So, because I know, since many of you have a lot of working experience, you know how to work in a team, right? So today, when you do software, you never do it by yourself. Okay, so there's always a cross-functional team, right? There's always a cross-functional team. When you bring DevOps, the cross-functional team, the number of different functions getting bigger. So everybody need to, another thing, by doing that is you learn to communicate. Okay, communicate with people with different background, communicate with people with different skill set, this is a complement. Yeah, so, 5 or 6 will be fine. Yeah. I don't know if you guys are going to stay with the same team or, so change is always okay. Any other question? Okay, thank you.